Alright, in this part of the video I want to talk about shaders. So all shader classes are derived from this base class, which does all of the compiling the shader, input layout, setting to context, all the stuff that all of them need to do. And then every shader inherits from that, like I said. The job of the shader classes is to make everything easier. So basically you can update any settings that you need. You can send constant buffers, update constant buffers as you need. And then the base class allows you to like set to context and all that. So I'll just focus on the texture light shader because it's the most useful one. In order to get multiple lights working, I have arrays for the point light data and the spotlight data, and then in the corresponding constant buffer as well. When you build the shader, you have to do the input layout and then reserve space on the GPU for the different buffers. So you view projection, light parameters, world of material, and then the fog data buffer that I added. When you delete, you have to release those COM objects, those constant buffer handles. Here's the different ways to send the matrices. So you update the constant buffer that you need to with the corresponding information. For sending the light parameters, you have to copy over all of the different light sources into the constant, or into this struct, and then send that to the constant buffer. Fog parameters is pretty simple. It's just those three vex, or not vex. This is a float vect for color. That's right. And then setting to context, call the base class, do the correct input layout. I do have to send the fog parameters every frame. Just because you need that information every frame. There are default values, so I should have showed that earlier, but there are default values so that if you don't, well, maybe I'll just do that. If you, in the demo, if you go down here and you just don't set any fog parameters, for instance, it'll just send, it still has to send information to the constant buffer every frame, I think. I don't think I could avoid that, but it will just be data that doesn't do anything. So yeah, there's no fog effect. Blah, blah, blah. Yeah, so that's kind of the wrapper class. In terms of the actual HLSL stuff, you have your different registers, so texture, sampler, all this stuff is just the math stuff for the light computation, and then here you have all the constant buffers, and these structures need to match on the CPU side, 1-to-1 matches. Oh, that's just math for lighting. Here's the vertex shader, doing some stuff, and the pixel shader doing some stuff. Here's where I added in the fog stuff right here. So after you calculate the lit color, then you need to add in the fog, like interpolation, with this function, and then you can return it. And I have done the fog in the texture shader as well. I had to add in not a lot, but you had to add in the eye position constant buffer, and you also had to change the VS output so that you could save the position separately and then pass that along. So anyways, oh, and you also had to have the inverse matrix available. So I had to do all that, but now the texture and the texture light can do fog. I didn't do it for the rest of the shaders. I probably should have done it for color light, but anyways, yeah, so I don't know if I have anything else to say about shaders. I think that pretty much covers everything, so I will stop this part of the video.